we now discuss the solution of a problem that has appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the ordinary differential equation in the given context in the given question paper. And the question is from the part B carrying 3 marks, and the question ID is 704042. The given question is the smallest real number lambda for which the problem minus y double prime plus 3y is equal to lambda y with the given conditions y at 0 is 0, y at pi is 0 has a non-trivial solution is, we are given 4 options. Let's now discuss the solution of this problem in detail. The given differential equation can be written as y double prime plus lambda minus 3 into y is equal to 0. Yes, we can write this differential equation as this one. Right. Now, to solve this one, we write its auxiliary equation, that is written as m square plus lambda minus 3 is equal to 0. This will give rise to m is equal to plus or minus under the square root of 3 minus lambda. Yes. Yes. Now we deal with the 3 cases. Case 1. Let lambda is equal to 3. If lambda is equal to 3, m is 0 and it is repeated twice. When it is repeated twice, the general solution of the differential equation is y of x is equal to a plus bx, where a and b are arbitrary constants. To evaluate them, we are given 2 conditions. Now, y at 0 is equal to 0, y at pi is equal to 0 will give rise to a is equal to 0 and b is equal to 0. How? Y at 0 is 0 means put x is equal to 0 in this. Y at 0 will be a only, and y at 0 is 0, therefore a is equal to 0. So, similarly, y at pi is equal to 0 will give rise to b is equal to 0. So, thus both the constants equal to 0, therefore y of x is equal to 0 for all x, and this is the trivial solution. But we are looking at the non-trivial solution. Right. Let's take the second case. Let lambda less than 3. When lambda less than 3, 3 minus lambda is positive. Therefore, m is equal to plus or minus under the square root of 3 minus lambda. Yes, that will remain same because 3 minus lambda greater than 0. And the gs is given by y of x is equal to a e to the power of square root of 3 minus lambda x plus b e to the power of minus under the square root 3 minus lambda x. Yes. Yes. We are very familiar writing this one. Right. Now, let us take the given conditions. Now, y at 0 is equal to 0, y at pi is equal to 0 will give you, y at 0 is 0 will give you a plus b, right, is equal to 0. Y at pi will give you a e to the power of under the square root of 3 minus lambda pi, yes, because x is equal to pi, plus b e to the power of minus under the square root of 3 minus lambda pi is equal to 0. Now, from the first a plus b is equal to 0, we get b is equal to minus a. Substitute in this. Then you will get b is equal to minus a, and e to the power of minus under the square root of 3 minus lambda pi is written 1 by e to the power of under the square root of 3 minus lambda pi, and taken the LCM. Then you will get a times e to the power of 2 times under the square root of 3 minus lambda pi minus 1 is equal to 0. Right. right? Now this will not be 0. This will not be 0. So in the bracket this is not 0. This will force A is equal to 0 and thereby B is equal to 0. So A is equal to B is equal to 0 you will get, since lambda less than 3, this is not equal to 0. So thus we get y of x is equal to 0 for all x. Again you get a trivial solution. We are looking for a non-trivial solution. We discuss in the next slide. Right. Now let's go to the case 3. Let lambda greater than 3. Then 3 minus lambda, yes, 3 minus lambda is negative, right? When 3 minus lambda is negative, under the square root of 3 minus lambda, that is, it is a square root of a negative quantity, you will get imaginary numbers. So you will get m is equal to plus or minus I into under the square root of lambda minus 3. Yes. Minus 1 we have taken out. And the minus 1 under the square root will be plus or minus I. Right. So thus we got the complex roots, and the general solution of the given differential equation is y of x is equal to a cos under the square root of lambda minus 3 into x plus b sine of under the square root of lambda minus 3 into x. Right. Again we use the conditions. So y at 0 is equal to 0 will give you, so substitute x is equal to 0, you will get sine is 0, so you will get a is equal to 0, right? And y at pi is equal to 0 will give you, a is already 0, so it will be b into sine of under the square root of lambda minus 3 into pi is equal to 0. And if you take b is equal to 0, then again a is equal to 0 is equal to 0 is equal to b is equal to 0, and you will get again a trivial solution, but we are looking for a non-trivial solution. Therefore b not equal to 0. If b 0, then we get a trivial solution, but we are looking for a non-trivial solution. Therefore b not equal to 0, and thereby sine of under the square root of lambda minus 3 pi is equal to 0. Then under the square root of lambda minus 3 pi is n pi, its general value, n pi, where n belongs to the set of integers. Now squaring, so pi cancel first, then squaring lambda minus 3 will give you n square, where n belongs to z. From this you will get lambda is equal to 3 plus n square, where n belongs to z. Now for various values of n belongs to z, what is the smallest value of lambda? The smallest value of lambda will arise when n is equal to 1 and n is equal to minus 1. So we are looking for n belongs to z only, right? And the smallest value of lambda is 4. So the smallest value of lambda is 4. At this lambda is equal to 4, we get a non-trivial solution. And we are looking for that value of lambda for which the given differential equation accepts a non-trivial solution, right? So thus the smallest real number lambda for which the given problem has a non-trivial solution is 4. Let's look at our options, and our answer 4 appears against option 4. Therefore the answer to this question is option 4. That is the detailed discussion of the solution of this problem, right? We make a remark in the next slide. So the remark what we are going to make is, this is all what we have done. M is equal to plus or minus under the square root of 3 minus lambda. And what it says is, look at the values of lambda that are given in the options. In the options, 3, 2, 1, 4 are given. They are all positive. That means you discuss the question when lambda is positive. And you can cut short case 1 and case 2. and directly you can come to case 3. Note, we see that the values of lambda given in options are all positive. Therefore, we cut short the way and we directly go to the case 3, skipping case 1 and 2, and proceed. And you will save some time by this one. But if you want the complete answer and the discussion, and that I have shown you in the last 2 slides. So that is the discussion of the solution of a given problem which is based on the concepts of ordinary differential equations. And I am sure that you understood the solution of this problem. If you like my videos, I mean, if you are an aspirant of IIT JEE mains, and if you are an aspirant of CSIR NET examinations, if you are an aspirant of TS set, AP set, etc. examinations, please like, share and subscribe my channel. I wish you all the best. Thank you.